Hello students, to Edubbey Global Solution. Now mathematics class again, we're going to be looking at another subtopic under our previous class, which is angles in shapes. In this class, we're going to be looking at different angles, triangles, quadrilaterals, and polygons. We're going to be looking at different angles in these shapes mentioned. We have our interactive content here that will serve as a guide for this class. Okay, so when you're talking about angle in shapes, the first one shape we're looking at here is a triangle. So we have a theorem that is backing the calculation of a triangle, or which says that the sum of the angles in the triangle is 180 degrees. So let's look at this on a triangle here. What this one is telling us that by the time we add all these angles inside this triangle together, the sum must not be greater than 180 degrees. So let's fix the activities we have here. The sum of an angle in the triangle is 180 degree. Okay, let's check. Okay, that's cool. Now let's look at the activities that we have that is related to the theorems under triangles, which says that what the sum of angle of a triangle is what is 180 degree. Now let's look at this triangle we have here. That's, we are told to calculate the size of the angle S in the triangle below. We have S degree, we have 37 degree, we have 64 degree. So all we just need to do is we are adding up all these degrees and we are equating it to 180 based on the fact that the sum of angle of the triangle is what is 180 degrees. So we have S theta. Okay, so if that is it, we can now get okay, so we have S degree plus 37 degree plus 64 degree equals 180 degree. Okay, now what is 37 plus 64? 37 plus 64 will give us what? That give us 101. So we have S degree plus 101 degree equals 180 degree. So we want to get X. We are bringing 101 to the other side. And charge changes to minus. So we have 180 degree minus 101 degree. That's 101. Okay. So 180 minus 101 will give us what? 79. Here is what is 79. So we have this to be 79. So let's put the right answer into the boxes because we already have the calculation here. So we have 37 degree plus 64 degree give 101, which is 101 plus x. So we want to get, okay, plus x, right? Okay. So you want to get, what is missing here? X is actually missing here because what we are calculating is, so if we have 180 minus 101, we are taking 101 to the other side, so it changes to what? Minus. So we have 180 minus 101 to give us what? 79 degrees. So let's check. Okay, that's cool. Now, let's look at the next angle that we are looking at. We are looking at quadrilateral. The quadrilateral below splits by drawing a straight line from one corner vertex to the other corner to form two different triangles. So if you look at this, we have made mention of quadrilaterals in our previous classes. Quadrilateral is a shape with what? With four sizes. So now let's look at this. If look, this is a quadrilateral. You know, there is a line in between that is drawn to divide this into what? Into two different triangles. So this make a triangle, this make another triangle, this is a triangle, this is another triangle. See that they have three sides. So having this, we can now say that the sum of each triangle is what? Is 180 degrees. So by the time you add the sum of all the four angles of the quadrilaterals together, it must be what? 360 degrees. So a triangle made up of 180, the angles of a triangle made up of 180 degrees, while the angle of a quadrilateral make up 360 degrees. Now let's calculate what we have here. Look at that. That is a quadrilateral. Why is it quadrilateral? You can see that it has a what? Four sizes, right? So we have to calculate the missing degree here, which is what? P. So all we just need to do is what? We are equating all the angles we have here to what? To 360. But note, look at this. This sign here is telling us that this side is a right angle triangle. So, and we have made mention of right angle triangle in previous class, which says that right angle triangle is an angle of what? Or 90 degrees. So that implies that this side as well is taking 90 degrees. We have 80 degree here, 60 degree here, and we have 3 degree here. Then we equate everything to what? Everything to 360 degrees. So let's start with P degree plus 90 degree, okay, plus 80 degree, okay, plus 60 degree, okay, equals what? Equals 360 degree. Now, what is 90 degree plus 80 plus 60? 90 degree plus 80 plus 60 will give us what? It will give us 230 degrees. So we have P degree plus 230 degree equals 360 degree. Now, equals to, okay, we have plus 230 degree now, comes to the other side of the equals to sign and changes to minus 230 degree because of the equals to sign. So we have P degree equals to 360 degree minus 230 degree. So what is 360 minus 230? 360 minus 230 will give us 130 degree. So P here that we have here is what? 130 degrees. So by the time we add 90 plus 130 plus 60 plus 80, the sum, it will sum up to 360 degrees. So let's drag the right answer to the boxes. What are we looking for here? We are looking for P, which is P degree, okay? Now, these rules here, we have minus 90 minus 80 minus 60 will give us minus 230. So 360 minus 230, what would that be? That's 130 degree, and that gives us a solution to the problem, okay? Now, let's look at polygon. That's another shape we want to look at. Angles in polygon, okay? So before we go there, let's define what a polygon is. A regular polygon is distinctive in that all its sides are equal length and all its angles are of equal size. So for a regular polygon, all its sides it has what? It has equal length and all the angles are also equal. So that makes a polygon distinctive. We have a regular polygon that makes up of what? All equal lengths. All the sides are equal length and all the angles as well are equal. Now let's look at what we have here. This is an hexagon. We treated polygon in our previous class. This is a pentagon which is made up of 5 sides. This is a square which is made up of 4 sides, and this is an equilateral that is made up of how many sides? 3 sizes. Okay. Now let's look at the sum of interior angle of a polygon. What happens to the interior angles of a polygon? The number of a triangle is always less than the number of the side of polygon. Yes. Now you know that triangles has 180 degrees. So the numbers of a triangle is always less than the numbers of a polygon. So that implies that we have n minus 2 triangle because it's less than numbers of polygon. Now, the angle of a triangle is added up to what? Angle of a triangle is 180 degrees. The sum of a triangle is 180 degrees. We have treated this in the very first slide of this class. Okay. Now, angle of a triangle will therefore be what? It will now be 180 degrees multiplied by n minus 2. So if you want to calculate angle of any given polygon, then the formula is what? 180 degrees multiplied by n minus 2. And that's what we are going to be using to solve these activities here. We have to find we are finding the sum of the interior angle of a regular pentagon and hence the sides of each interior angle. So we want to know the angles of a regular pentagon. What makes a pentagon? That implies that we must have 5 equal sizes. So the numbers of a pentagon, the number of sides of a pentagon is what? Is 5. Okay, so having that, and we have told us that if we want to calculate a polygon, the formula is 180 degrees multiplied by n minus 2, where n means the numbers of the sides of that given polygon. So this time around, our pentagon is what? Our pentagon is 5. It has 5 sides to make up of the shape. Okay, so having that, instead of n here, we replace our n with what? With 5. So we are 180 degrees multiplied by 5 minus 2. What is 5 minus 2? That is 3. So we have 180 degrees multiplied by 3. So what is 180 degrees multiplied by 3? That is 540 degrees. So the sum of the interior angle of a regular pentagon is 540 degrees. Now we want to get each side. And we are told that the number of sides of a pentagon is what? Is 5. So to get each side, all we just need to do is we divide the sum of the interior angle of that pentagon with the numbers of sides. So it's going to be what, 54 degrees divided by 5. We want to get the size of each angle. That's what we need. Size of each angle. Okay. So how many times can 54 actually go? 5 goes in 5. 5 goes in 5 one time. Okay. Okay. Now 5 can go in 40. How many times? 5 can go in 48 times. So each size of that polygon is what, 108 degrees. That makes each side. So if you want to confirm if we are actually right, just multiply 105 times 5 and see if we are going to have 540 degrees. So if you get that, then that implies that each side of an exterior angle of a polygon is 180 degrees. So let's put the right answer inside the boxes. 2 will give us 5 minus 2 will give 3. 3 times 180 will give 540. To get each angle of that polygon, we need to divide 540 by 5, which gives us 108. Okay, so let's check. Okay, we are whole. Now let's look at the sum of exterior angle of a polygon. You know, what we look at was what? Was interior angle of a polygon. So then look at this shape. We have this shape here. It is being marked from what? From A to F. If you study here, we have A, B, C, D, and F. Okay, so the angle marked A, B, C, D, and F in the diagram below represent the exterior angle of a regular hexagon. What makes an hexagon? Hexagon has how many shapes? 6 shapes. If you count how many sides we have there, you know that it's going to be 6 shapes. So that makes a hexagon, right? If the polygon is regular and has n sides, then we said that each exterior angle is going to be 360 divided by n. So for us to calculate each size of an exterior angle of the polygon, we have our formula to be 360 okay, divided by n, and that gives us the each angle of an exterior polygon. Okay, now let's look at this. We have an activities here related to that. We want to know the angle of that exterior polygon. So the first one said that we should find the size of an exterior angle of a regular nonagon. What is, when you're talking about nonagon, I think nonagon is 9, right? Under various polygons that we have. So nonagon gives 9 sides rather. So if that is the case, then we can now have the size of the exterior angle to be what? 360 degrees divided by 9. So since n is what? N is 9, number of sides of an angle. So by the time you divide 9 by 360, it's going to give us 40 degrees. So each side of that angle of a nonagon here, the exterior angle of a nonagon here, each side is 40 degrees. Now we have to calculate the number of sides of regular polygon if each exterior angle is 15 degrees. So for this angle here, we have already gotten our angle to be what? Our angle is 15 degrees. What we need to calculate is the what? Is the number of sides, which is n. So all you just have to do is we have 15 degrees equals to 360 divided by n. Then we cross multiply, right? So n will multiply 15, that is going to be 15n. Remember, we are dealing with degree equals to 360. We want to get n, which is the number of sides of that regular polygon. So we divide through by what? 15 degrees. So we divide the other side by 15 degrees. Okay, so having that 15, we cancel 15, we have n left here. How many times can 15 goes in 360? That is 24. So each side of that regular polygon is 24. So let's put the right answer in the boxes here. The nonagon is how many sides? Is 9 sizes. It has 9 sizes. Okay, so to calculate each exterior angle is going to be 360 divided by 9, which is what? 40. Now the next example here, they did not mention the specific polygon. It's just a regular polygon with what? With exterior angle to be 15 degrees. So we want to calculate the number of sides. So what we just need to do is what? We equate n to be 360 divided by 15. And 360 divided by 15 will give what? Give 24. and that gives answer to the problem. Okay, now let's look at the past question that we have here. We have this. The diagram shows the angle in the triangles and two angle on a straight line. Okay, so the first one here says that the triangle is used to write down an equation in terms of x and y. This is a linear equation. We know that the sum of the angle of a triangle is what? Is 180 degree, and this is what fulfill the reason why this equation is being written in this form for this angle, because if you have this, it's going to be 2y at this 2y plus x plus s equals 180 degree, and x plus s, that is 2x, so that we have it to be what? 2y degree plus 2x, okay, equals 180 degree, or the other way around, 2s degree plus 2y degree equals 180 degree. So the reason why this is being written this way is because the sum of the angle of the triangle is 180 degree. Now the second one says that use the diagram with two angles on a straight line to write down another equation in terms of x and y. So this is a angle on a straight line. The sum of angle on a straight line is also what? It's also 180 degree. So if you have to write this, then the equation is going to be x degree plus 6y degree equals 180 degree, because the sum of angle on the straight line is 180 degrees. So now, if you want to calculate x and y, want to get x and y out of these two given diagram, what we just need to do is, this is two linear equation that we can now solve simultaneously. So we can use any method of simultaneous equation that we have treated in our previous classes, which is the elimination method, or what? Or substitution method. So in this case, because of this class, we are going to be making use of what? We are going to be making use of elimination method. So for us to eliminate, let's make this one equation 1 and let's make this equation 2. Okay, now to eliminate, one of the term must be equal. So what we need to do is what? To multiply equation 2 by 2, so that we can have 2x and we have 2x as well in equation 1. So we have 2x plus 2y equals 180 degree. Remember, that's our equation 1. Okay, now 2x, the second equation now is going to be 2 multiplied by 2, which is 2x. Okay, 2 multiplied by 6, that is 12y, equals to 2 multiplied by 180, that is what? 360 degree. Now, so we can now have our negative sign here and subtract, so that x will be eliminated. We can know the value for y. So 2x minus 2x will give us 0. Okay, plus 2y minus plus 12y will give us what? That will give us minus 10y, because minus times plus will give us minus. Okay, 180 minus 360 will give us what? Minus 180 degrees. So we are dividing both sides by what? Minus 10. We divide both sides by minus 10, right? So the 10 will cancel 10 here, minus will cancel each other. How many minus can cancel minus here? So we have y equals to 10 can go in 180 18 times. So y equals to 18. Now, after getting y equals to 18, let's put y equals to 18 in the second equation here and solve for x. So whenever we see y, instead of having y, we are going to be replacing with what? With 18. So we have 18 multiplied by 6 equals to 180 degrees. 6 times 18 is what? What is 6 times 18? 6 times 18 will give us 108. So we have plus 108 equals 180. So 180, okay, degree, okay. So plus 108 goes to the other side and changes to minus. We have x equals to 180 degree minus 108. So 180 degree minus 108, what is that? That is 72 degrees. So x is 72 degree, y is what? 18 degree. This takes us to the end of our class. We want you to subscribe to our channel www.edubbey.com for the full interactive content of this class. Thank you for listening.